Number 35, a mass of 0.5 kilograms. So we have a half a kilogram mass. Oscillates on a simple pendulum with a length equal to 1.5 meters. And it's a pendulum, right? It reaches a maximum height, so height max is going to be 0.08 meters. And part A wants to know what's the maximum gravitational potential energy. So in a pendulum, the total energy equals kinetic energy plus GPE. And if we have a pendulum that's swinging back and forth, its maximum gravitational potential energy is going to be when it's at point here and here. And you can see as it's swinging, it has a good velocity, but as it goes up, its velocity will eventually stop and get to zero before it starts returning and going that way. So it has all GPE at this point and at this point, and no KE, because it actually stops moving for a split second before reversing direction. As it falls down, as it passes the this equilibrium point, it has no GPE, but it has KE because it's moving. So the maximum gravitational potential energy would be here when it has no kinetic energy, or the kinetic energy is zero. So the total energy of the system is going to be all GPE, and GPE equals mgh, and plug in our numbers, 0.5 times 9.8 times 0.08. We get GPE max equal to 0.392 joules. B, what's the maximum kinetic energy? Well, we said the total energy is equal to KE plus GPE. And we said when there was no kinetic energy, that GPE equal to total energy. So when there's no GPE, that total energy is going to be all kinetic energy, which is 0.392 joules again. C, what's the total energy of the system? The total energy of the system, we said twice already, is 0.392 joules. So the energy is always the same. It's 0.392, 0.392. At here, it happens to be all GPE, and at here, it happens to be all KE. D, what's the maximum speed? So the maximum speed is going to be when it's all kinetic energy, it's maximum kinetic energy, and that's going to be 1/2 mv squared. So to get v by itself, we're going to have to multiply both sides by 2. So we have 2ke equals mv squared. Now we have to divide both sides by m. And ultimately take the square root. Plugging in our numbers, we have v equals square root of 2 times 0.392 divided by a mass, which is 1/2. And I don't even know if I have a room for this. And we have a velocity equal to 1.25 meters per second. And E, at which point is the maximum speed reached? Well, the maximum speed reached is when it's at x equals 0. So for E, V max is going to be at the displacement equal to 0, which is known as our equilibrium point.